Morning. I welcome you all to this session on regularization techniques in classification. As we all know, data is given as input to a machine for training. It understands and identifies patterns and relationship in the data. The model is later evaluated and tested. Problem of overfitting. When we train a classification model, it tries to find patterns in the data. Sometimes it finds too many patterns. For example, if we teach a model to recognize cats, if 10 cats are given to them to recognize, they might remember every single pattern of the image, probably including the entire elements that are present in the ambience or the environment of that particular cat. For instance, that might include the carpet on which the cat is sitting, the plants around, or other background details, the curtains, the window frames, etc. So they would be able to identify those cats, but not other cats in general, because they would try to look for the same carpet or same background in the other images too. So they might not recognize a cat even if the right cat image is shown to them. So this is what is called as overfitting. The model is too focused on the training data and it does not generalize well. So what is regularization? It is like a discipline rule for the model. It is more like telling to the model that don't unnecessarily memorize everything and just looking for the important stuff. So a simpler model performs little worse on training data but works better on unseen data. So regularization is a method that is used in machine learning to prevent overfitting. So when our model learns the training data too well, including noise, here noise means unnecessary information, outliers, then it performs poor on the training data but works better on unseen data. So I just wish to give an analogy here. It is more like learning every single data in the book. A page of a book carries so many data. It should have a pause, a full stop, an exclamatory, a question mark, a page number, whatnot. Those unnecessary elements that is nowhere related to the content. What if that also has been observed? So every single thing, the brain focusing on every single thing, leaving the core matter, wastes a lot of brain's potential. So why regularization is required? Overfitting problem, in such case, model fits the training set too perfectly. So it is a bad generalization. And there is high variance, that a small change in the data would lead to big changes in the prediction. So the goal is to keep the model very simple enough to generalize things well. Ridge and lasso. These are two different techniques of regularization. Ridge is also called as L2 regularization and lasso is called as L1 regularization. Now it is used in linear regression to prevent overfitting by adding penalty to the cost function. Ridge, which is L2 regularization, adds penalty. Both methods, be it L2 or L1, it adds penalty. But L2 adds penalty proportional to the sum of squares of the coefficients, whereas L1 regularization, which is lasso regression, adds penalty proportional to the sum of absolute values of the coefficient, that is mode of the coefficients. Both model reduces complexity and prevents overfitting. So these are all the metrics that are used to measure the performance of the models. So the metrics that are used for measuring the performance are MAE, mean absolute error, mean squared error, root mean squared error, Huber loss, and R2 square. These are the methods known as performance metrics. What is a cost function? It is a function that gives us a single value which tells how wrong our model is. Actually, it is the difference between the model's prediction as well as the actual result. So our goal in machine learning is the value what we find out, that is the difference between this prediction and the actual result, is a value that should be less as much as possible. So the model does some prediction and the actual result is given in the data. We need to find the difference between these two and square it. This is what is actually done in the cost function. That is prediction minus actuals. The obtained value is squared. So our goal is to minimize the cost function. L2 regularization. Rich regularization, as discussed earlier, adds a penalty proportional to the square of the coefficients. So cost function is equal to sum of squared errors plus lambda into the slope square. Helps prevent coefficients from becoming too large. It produces smoother and more stable models. So lasso, L1 regularization. It adds penalty proportional to absolute coefficient values. That is, cost function is equal to sum of squared errors, which is added on with lambda, wherein the constant value is already given. That is multiplied into the absolute value of slope. So it can shrink some coefficients to 0 and perform feature selections. This is very useful when we deal with high dimensional data. So let's look into a small example. So this is simple linear relationship. Y is equal to 2x. Model fits training data perfectly when sum of squared is 0, which means overfitting. So this rich or lasso penalty improves generalization, adding values proportionally. Regularization balances accuracy as well as simplicity. Let's take an example. Observe the value of x and y. If we observe the value of y, it is 2 times of x. This can also be written as y is equal to b naught plus b1x or y is equal to mx plus b. When x is equal to 0, y is also equal to 0. If b naught is equal to 0, substituting b naught, it is 0 plus 2x. So y is equal to 2x. So b1 is equal to 2. So overfitting reduces models' performance on unseen data. Regularization in general prevents overfitting by penalizing complexity. So the right balance leads to better generalization and reliability. Thank you very much. I hope this session would be of great use to you. Thank you.